in this question we have to first show that two lines intersect, and then we have to find that point of intersection. It is very important to understand whenever you are finding the point of intersection, it's always the position vector. Now why does this happen? Why are we talking about the position vector? The reason is, what does this mean? This is one line, vector line called L1, and this is another vector line called L2. So what does it mean when we are referring to this small letter r? Well, it refers to a position vector. So let me show how this works. This is a very important concept. When we have a vector, suppose this is the official definition of a vector line. If a line passes through a point A and another point B, then the vector line is represented by this. For some arbitrary point, let me call that arbitrary point X. So this position vector, arbitrary position vector OX, is represented by this R. This is very important. So R represents the position vector. Now how does this work? Well, R equals to, by the rule of vector, this is OA and this is AX. So R equals to the vector in the clockwise direction, which is OA, plus AX. This is what R is all about. Now we know OA, this is given, and we know the direction vector AB, or any vector parallel to this. We know the direction, but we don't know how long this is. So we write it as a scalar, lambda AB. That means the position vector, any arbitrary point, how far this X is depends on the value of lambda. That means the longer this line AX is, the higher the value of lambda. So every individual value of lambda represents a unique point on that line in the same direction. So when we are talking about line L1, it's some sort of a position vector. Let me call that OX. And when I'm talking about another one, L2, we're talking about another situation where you have OY, and in that case it is going to be mu. In that case it would be, suppose it goes to another point B, it would be OB plus mu, some other direction vector. Notice the direction vector over here is different from the direction vector over here. So that direction vector is going to be different, and the scalar, how long that is, we're going to using some other direction vector. So let me call this simply direction vector. So every time we are seeing the equation of a line in the format of R, it is simply an arbitrary position vector. Now what does it mean to find the point of intersection? Well, point of intersection means a common point. If this OX and OY intersect, it means this X and Y are in the same position. That means they are one above the other, like some sort of a congruency. A congruency is taking place like this, more like this. So O is over here and X is over here, and at the same time Y is also over here. So it means the lambda and the value of mu is such that they are merging together. So this is how the whole thing is working like. So first of all, let's write this L1 into the position vector format, meaning in the IJK vector format. This is particularly in the point and direction vector format, because we have a point and we have lambda direction vector. So the IJK format would be 11i plus 4 lambda I. It's going to be 11 plus 4 lambda I plus 5j plus 2 lambda j. So 5 plus 2 lambda j, if we take the j common, 6k plus 4 lambda k is going to be 6 plus 4 lambda k. This is L1. So this is L1. Now L2. So L2 is going to be 24 plus 7 mu I, then 4j, this is mu into j, 4 plus mu j plus 13 plus 5 mu k. So now that we have the format in IJK, so we can just compare I equal to I, because when they intersect they're in the same position. So we can write 11 plus 4 lambda equals to 24 plus 7 mu. And if we simplify, it would be 4 lambda minus 7 mu equals to 24 minus 11. It's going to be 13. This is equation 1. And now we have j equals to j. So the second equation would be 5 plus 2 lambda equals to 4 plus mu. So this turns out to be 2 lambda minus mu. 4 minus 5 is minus 1. This is equation 2. And we can also take the third equation, but we don't need that in order to solve lambda and mu. So we can solve it. So equation 1 and equation 2, what I can do is I can multiply equation 2 with 2. So 4 lambda minus 7 mu equals to 13. And if I multiply this with 2, it turns out to be, if I multiply this with 2 later on, it turns out to be 4 lambda minus 2 mu equals to minus 2. Now let's change the sign and use the method of elimination to solve this. This 2 cancels, this becomes minus 5 mu, and this becomes 15. Therefore, mu equals to minus 3. And if we put this in any one of the equation, it turns out to be 4 lambda minus 7 into minus 3 equals to 13. We are putting mu over here. So this turns out to be 4 lambda plus 21 equals to 13. Therefore, 4 lambda 13 minus 21 is going to be minus 8. Therefore, lambda equals to minus 2. Now, we found the value of lambda and mu. Now, the question is, how do we show that the lines intersect? Well, what I really prefer to do here is put the value of lambda in here and put the value of mu in the second equation, the IJK format, and see whether they're exactly the same or not. If they're exactly the same, that means they are in the same position and it intersects. But in this particular question, the question is separated. First, we have to show, and second, we have to find that point of intersection. So it means this work has to be done in question number B. So is there any shortcut of showing that L1 and L2 intersect or not? Well, there is. What you do is, when you have a question where you first have to show that the lines intersect and then you have to find that point of intersection, it's a different question. In this situation, you can do this by using the third equation and seeing whether the third equation holds true for the value of lambda and mu. If it holds true, therefore the lines intersect. You don't have to find the point of intersection to prove that. So let's find the third equation. So let me do it over here. Okay. For k equals to k, so the third equation is 6 plus 4 lambda equals to 13 plus 5 mu. So it turns out to be 4 lambda minus 5 mu equals to 13 minus 6, that is 7. So let's check. When lambda equals to minus 2 and mu equals to minus 3, let's check whether this holds true. 4 minus 2 minus 5 minus 3 equals to 7. So 4 into minus 2 is minus 8, and this is plus 15 equals to 7. Therefore, 15 minus 8 is 7. 7 equals to 7. You say, since it holds true, the lines intersect. That's it. Since it holds true for the final equation, the lines intersect. In this case, you don't have to put the value and find the position vectors. That would be for the next question, question number B. Okay, so let's find the position vector. Now that we know that the lines intersect, you can find the point of intersection either with lambda equals to minus 2 or with mu equals to minus. Let me show both. So question number B is going to be when lambda equals to minus 2. So the position vector is going to be, I'm putting it over here, 11 plus 4 into minus 2 I plus 5 plus 2 into minus 2 j plus 6 plus 4 into minus 2 k. And this turns out to be 11 minus 4 to the 8. 11 minus 8 is 3 I. 5 minus 8 is minus 3 j, and 6 minus 8 is minus 2k. I didn't understand my own handwriting. I think this is minus 2. So then it would be 5 minus 4. This would be plus 1. This would be plus 1. Okay, now it's all right. So this is it, and they said we have to find the point. Be very careful what they ask for. It's the coordinates of the point. We found the position vector. So the answer would be 3, 1, minus 2. Now let's check with the alternate method. So the alternate method would be putting mu equals to minus 3. Let's check whether it works or not. So if we put mu equals to minus 3, it would be 24 minus 7 into minus 3 is 21. So 24 minus 21. So 24 minus 21i plus. Then we have 4 minus mu is 3. 4 minus 3. So 4 minus 3j. Then we have 13. 5 into minus 3 is 15. 13 minus 15. So 13 minus 15k. This turns out to be 21 minus 20. 24 minus 21 is 3i. 4 minus 3 is 1j. And this is minus 2k. So the point is still 3, 1, minus 2. And that's the answer. Now this one is finding the angle. So we have to find the angle between these two lines which intersect. So this is and this. So they intersect at a particular point and we have to find the angle. So the angle is this angle theta. Now in order to find the angle, you have to remember the concept of parallel lines. The direction vector this, which is the same as the line L1, and the direction vector of L2, if you extend them, they're going to meet at a point, and by the rule of parallel lines they're going to be exactly the same as this. So finding the angle between these two vectors is the same as finding the angle of the direction vectors. So these are the direction vectors. So over here, so this is the direction vector for L1, 4i plus 2j plus 4k. 4i plus 2j plus 4k. So this is the rule for finding the angle between two vectors. So cos theta equals to direction vector 1 dot direction vector 2 divided by modulus of direction vector 1 multiplied by modulus of direction vector 2. So let's do this. So this is going to be cos theta equals to 4i plus 2j plus 4k, this is direction vector 1, dot 7i plus j plus 5k, this is direction vector 2, divided by modulus of direction vector 1 is going to be 4 squared plus 2 squared plus 4 squared, square root of 7 squared plus 1 squared plus 5 squared. And remember how we do dot product. In order to do dot product, we multiply the coefficients of I with I. So that means 4 into 7 plus then j with j, 2 into 1 plus k with k, 4 into 5. So this is going to be square root of 4 square is 16 plus 2 square is 4 plus 16. Square root of 7 square is 49 plus 1 plus 5 square is 25. So this turns out to be 4 sevens are 28 plus 2 ones are 2 plus 4 fives are 20, and this is 50. So this is 50. Now square root of 16 plus 4 is 20. 20 plus 16 is 36. So square root of 36. And then 49 plus 1 is 50. 50 plus 25 is 75. So when we find this value, it's going to be theta equals to cos inverse. Oh, we don't have to find the value of theta. All we have to do is find the value of cos theta. Okay. So cos theta equals to 50 divided by square root of 36 is 6, and 75 can be written down as this is 50 plus 25 is 75. 75 divided by 5 is 15. So this is going to be in terms of, so 25 into 3, 25 into 3, so it is equals to 50 by 6. Square root of 25 is 5, square root of 3, so 5 tens are 50, 2 fives are 10, 2 3, this is going to be 5, 3 square root of 3. Now if you want to rationalize this, you have to multiply by root 3 divided by root 3, so it turns out to be 5 root 3. Root 3 into root 3 is 3, and we have 3 downstairs, so that is 9. 5 by 9 square root 3.